So I hope everyone had a good Christmas break. So this is our first Antrea community meeting of year 2020. And I think starting today, we're going to move to a bi-weekly cadence. So there will be no meeting next week, but the next meeting will be in 2 weeks. And Sue has joined today, and I think he's going to present his proposal to support new encapsulation modes in Antrea, and that's a main item on the agenda, I believe. I don't think Salvatore mentioned anything else. So Sue, do you want to go through your proposal?
Sure. Thanks, Antonian. I can share my screen, right? I guess.
Yeah, you should be able to share, yeah. Is there an issue or?
Yeah, it looked like my security is not sort of setting up there. Let me see this one.
Did you upgrade to Catalina? You have to authorize Zoom to share a screen.
Yeah, actually, Antonian, why don't you share? You have the access to the document, right? Maybe I'll just walk through the document, right? Yeah.
All right.
That'd be nice. Okay, thank you. Yeah.
Okay. Let me know. I'll try to keep up. But let me know from.
Okay. Cool. So we're proposing to expand the encapsulation mode for Antrea. Today we only have encapped mode where internal power traffics are transmitted on wire via VXLAN. We don't necessarily need that. We can potentially have a internal pod traffic just using the pod's native IP addresses. So that's the proposal we have. Essentially, we're trying to adding additional mode. One is no encap, where the traffic between node, the pod traffic between nodes will not be encapsulated. However, because in this mode, the pod's IP address are not known to the underlay network. So if we're going from pod to external site, you would have to still doing the masquerade in this case. So what we're saying is that pod to pod traffic are not encapsulated and will have its pod's native IP address. Pod to external site or pod to a node will have the source IP address being masqueraded as node IP address, and the destination address will be the whatever destination IP address will be. By the way, if there's any questions, please let me just interrupt me. Maybe I can explain better. Another mode is what we call the hybrid mode. In hybrid mode, what we're saying is that Antrea trying to be smart to detect whether an internal pod traffic requires encapsulation or not. How do we do that, right? So we do that by detecting the node's IP address, whether the node IP address belongs to the same subnet between the source and destination or different, right? If they're different, if the source and destination IP addresses of the node are on different subnet, then we're thinking they must be on a different physical segment, then we use physical encapsulation. However, if they're on the same subnet, then we're assuming that they must be on the same physical segment as well. Therefore, we don't need to have encapsulation. Okay. The last mode is no encap, no masquerade. By the way, this name is temporary. I think Genji mentioned this is not a good name. I think I agree. Essentially, in this mode is that we're saying in this mode is that the the POTS IP addresses, the POTS CIDRs are known to the underlay network, are given by the underlay network. In this case, there's no encapsulation, number one, and there's also no masquerade, because if the underlay network knows about the POTS IP address, they know how to direct traffic from external side to the pod. Therefore, there's no masquerading required. In addition to that, we also have to have an argument when we start OVS, when we start OVS, what we call a uplink, where essentially allows us to assign uplink to a transport bridge. I think I just added a new session about the reasoning for adding this transport bridge. I guess we'll go through there. After this one, I think we're gonna have some questions regarding to why do we need transport bridge, etc. Okay.
Before we move on, I have one question.
Sure.
I know you said the naming was temporary, but would it make sense to make the masquerading like a separate dimension, like have a new configuration parameters that just says, do I want to masquerade traffic to external destinations, and just like make this orthogonal to the encapsulation?
I haven't thought about that. The reason I haven't done that is just because for me, this is really just essentially this mode is basically where delegate the routing side of things entirely to the underlay network. The Antrea in this aspect only worry about ingress and egress services, be that mirroring, be that firewall rules, etc., etc. It does not involve in routing in whatever matters, right? So essentially, whatever the containers IP addresses, containers MAC addresses that it transmitted will be sent on the wire as well. So that's the way I look at it. I don't know whether there's need for another dimension. At least that's how I see it, because it makes no sense to have it's essentially everything. If we have a overlay network, essentially, I'm sorry, take it back. Essentially, if for any time when we have a IP pool manager, like today, right? We always have the node IP pool, right? Whenever we have node IP pool, that means the IP addresses of the pod are not known to the underlay network. We always has masquerading anyhow. So there's not much of added
that makes
value.
sense. Or maybe if we, I think, are you just saying that if we have an overlay network, then not doing masquerading doesn't make sense, basically, because we have an overlay network? Yeah.
So essentially, this mode is that whatever the MAC or IP generated by the container will be transmitted on wire, right?
Yeah. So another thing that I feel it's not just about IP masquerading, because in the public cloud case, there are some layer 3 cloud, for example, Azure VNet. Probably also need to do MAC rewrite and then some R proxy. So
I haven't thought about. I haven't really looked at Azure yet. I know in AWS that this assumption right now here is that whatever the MAC addresses, IP addresses generated by the container will be appear on wire. Now, if this assumption is not correct for Azure case, then we have to do some additional massaging in the wiring code. But today, when I see this, when we say this no encap masquerade, it essentially means the IP and the container has the full access of the underlay network, right?
Mm-hmm.
Yeah. I haven't had a chance to look at Azure yet, but yeah, once we have this thing working, then we can look at Azure and see what additional work we need for Azure.
Another thing to consider on the masquerading is a separate dimension, is a lot of times the masqueraded address is used as a selector and filters that are, upstream of the actual cluster, right? So if I have existing firewall infrastructure, I may only want to let certain traffic through that's masqueraded as a certain address. And so we may want to keep that configuration concern separated.
So you're saying that you're saying max reading not, because essentially max reading really means that the IP address of the outgoing interface, right?
I understand.
Right.
And that's what I'm talking about. So allow basically egress filtering that's upstream of the cluster.
Upstream of the cluster.
Cody, are you saying you want to specify different SNAT IP? That's what I mean.
Well, I'm saying that, for example, in some of the enterprise, like at the bank, for example, the cluster was, the entire cluster was running on a network segment where egress was controlled, right? And sometimes egress is controlled by the source IP address that it's coming from, like what nodes are allowed to egress. And one of the ways that you could enable a pod to egress externally from the segment that it was in at a firewall that was not part of the cluster was controlling which IP address that its external traffic masqueraded as.
See, the thing about this no in cap masquerade really means that the container's IP address is known to the underlying network, right? So it's essentially, if you want to set, so essentially the external firewall should be able to setting up.
Yeah, in that case, that makes sense, right? Because the IP address is there's no overlay really in that in that regard.
Precisely, yes. So,
but but I'm saying in the ones where there are overlays, sometimes it is used as a selector.
Right. Exactly. So whenever we use the pod IP pool as we have today for encapsulate, as we use today, we also use encapsulate masquerading, no exceptions. The no encap masqueraded only works when the pod CIDR is assigned by the underlay network. If that makes any sense.
Right. And right now we only support masquerading as one specific IP address per node.
That's right.
What I'm talking about would be a situation where you might have multiple IP addresses assigned to the same node. So that's a different situation.
Okay. In that case, I think that should be okay still, because if you have multiple interfaces, then masquerading gonna be based on the outgoing interface, right?
Cody, I think you mean you have multiple IPs on the node, and you want to be able to specify which IP to use for SNAT?
Correct.
I guess that's probably another feature in my mind. I don't know what you guys think.
Yeah.
Right.
Yeah. And this max reading also works because so max reading means the IP of the outgoing interface, right? If your routing dictates your the outgoing interface is different than are different than masqueraded IP address would, SNATed IP address will be different, right? So that is controlled by routing table, not controlled by whether to have masquerade or something like that. Oh, anyhow.
Yeah, that makes sense. Okay. Let's move on.
Yeah. Okay. So I'm getting a lot of questions regarding to the need for transport bridge. But this additional physical bridge, this is my thought process, right? The transport bridge allows the pod to have direct access to the uplink, so that it can send, receive unencapsulated traffic directly via the uplink, right? So it has two advantages per se. One is that it's consistent with existing Antrea's networking mode, where all the pod-to-pod traffic are routed within OVS, and only two service traffic are load balanced and then routed back to the integration bridge and send, right? So that's we're trying to still reuse the existing the workflow, so we don't have to worry too much. We don't have to deviate too much from the existing working mode. Another advantage would be that it makes the integration bridge secure, right? So in this case, all the traffic within the integration bridge will be either from or to the local pod. There's no exceptions, right? So we don't have to worry about any of the traffic on wire that be accidentally being or getting into the integration bridge, right? I also listed a couple of the alternatives. One is that we can potentially just directly adding uplink to the integration bridge. I normally would not recommend this approach because if the integration bridge is if it's in standalone mode, that means any traffic that doesn't have a flow will be handled as a regular Linux bridge. That means if you have a bump traffic, all the traffic will be sent to all the the containers. Even if you have the network policy rules, it doesn't matter. However, if you set your failure mode to secure, that means any traffic that don't have any matching flows will be dropped. It's pretty difficult to predict what exactly are the flows that is required by the host network stack, right? Let's imagine the host might need SSH, the host may need some kind of service, etc. The other approach that I really haven't think very carefully about in my work is actually as we use a separate uplink just as this is today in the encapsulation mode. In this case, we'll have to be able to route the pod-to-pod traffic in the host network's namespace. I guess it can be done, but it's specific to each of the maybe environment. It can be pretty messy. That's why I also not spending too much time on that.
Yeah, sure. I think the second one, I'm not sure, but maybe it could work. But the thing that it will have some performance downgrade, I believe. I mean, I guess you mean you want to do Linux routing from the bridge to the uplink interface, right? By the second approach.
The second approach is basically, you mean the alternative one?
Alternative two, actually, sorry.
Alternative two means that actually the network configuration stays the same as it is today, where you have an integration bridge, right, which does not have any of the it doesn't have access directly to the uplink. Uplink is separate, right? Just as it is today. Then when the traffic coming out of the gateway 0, right? Then we'll have to be able to route the pod traffic inside the host namespace, right? So that's it can be working, but it's a little bit tougher. It also depends on the environment. So that's
I got what you mean. Maybe it could work, but I guess it has same problem as your physical bridge for service traffic. But what I mean that it will have some performance downgrade compared to you have the uplink and OS bridge. So I don't support that approach either.
Okay. So that's my rationale now. I think there's quite a bit of discussion regarding whether or not we should adding this the transport bridge. Do we have any questions, suggestions what we should do?
I have a question. Are you splitting concerns for security between both network policy and conflating that some with how the network is, or I'm sorry, the traffic is being transported across those two different bridges, you said it would eliminate bum traffic, right?
Yes.
Do we want to relegate that entirely to policy configuration to eliminate that so that that concern is in one place? And furthermore, what about NFV, right? Where they may want exposure to some of that traffic.
Right. So I think we're looking at alternative one, right? So if we use a transport bridge, then there's no bump traffic in the integration bridge, right? Then we're safe, right? So all the rules are specific to power traffic, then we're safe. But if we're using alternative one where we're adding the uplink to the integration bridge directly, then if we run the integration bridge in standalone, then it's not safe. Then regardless whether there's a policy or not, the bump traffic will be arriving at the pod. Does that answer your question, or?
No, I understand how the traffic arrives. I think my question was more on, are we doing this because we feel that the network policy is not sufficient in that particular case, right, to protect against that bum traffic, right. Or are there cases where that bum traffic actually might want to be seen in a network function virtualization scenario?
Well, in the container case, I don't see why bump traffic will be required, right? So at least today in our policies, we don't. The only thing that actually potentially we have is our broadcast. Everything else should be unicast, generated from the pod and received by pod.
So Claudia, I haven't thought about NFV. I guess you mean something like network service mesh or some layer 2 network required by NFV. I haven't thought about that yet. Maybe it requires multicast and broadcast. But I guess Shu's main point is that if you have both physical interface and port interface on the same bridge, you may need to change your flows for the physical interface because it has different requirements regarding to the traffic forwarding, including policy and bump, and maybe some other traffic. I'm not very sure about that, but I think that's a main point from Shu.
So essentially, a OVS bridge can operate in two modes: standalone and secure mode. But in standalone mode, that means all the traffic that missing any flows will be handled as a regular Linux bridge, right? That means traffic. If it's broadcast traffic, the traffic will be sent to all the ports on the bridge, right? So that's applied to bump traffic.
Yeah, but on the other hand, Shu, again, I didn't look into details, but I kind of believe it's still doable. And we do have that solution before with NST. So
NXT we don't. You talk about NXT?
No, I'm not talking about the cloud. I'm talking about the NST container plugin.
Yeah.
Since I didn't look into details, probably I cannot argue for that. I just want to raise my concern for these two bridges. Yeah, I also comment on the doc. My only concern is like for people who don't know much about open switch, I'm not sure they will feel like it's too complex. I mean, even one bridge, maybe to them, it's already a little complex because they don't know open switch. So, you tell them there are two bridges, maybe they will be further scaled.
Yeah.
I don't know.
So I think that's a fair point. But I think if you're looking at OVS, if people are familiar with OVS, right, it's a standard practice to not have the uplink directly attached to the managed bridge. It's always like that. It's just not new. This is standard practice.
Yeah,
I think OpenStack does it as well.
That is true.
And
so I'm not reinventing the wheel. I'm just trying to do the right thing. There must be the reason they do that is for security reasons. So
And what kind of flows would we need to install in the physical bridge?
Nothing. You just create, the physical bridge is going to be a standalone bridge. There's nothing.
Yeah, that's what I thought. So I kind of feel like it doesn't really make things like much more complex, right? Because we don't really have to control that. So it's just,
No, we don't.
just
It's created by the script. It's going to be created by the start OVS, and we're done with it.
So yeah, maybe it makes the architecture picture a bit more difficult, but from the code perspective, it's
that is true. I think for people understand the code and understand the flows, probably it's even simpler. But for people don't understand what is, and they just look at the bridge and they say IP is on the bridge, whatever. Then they need to understand there's another bridge, and then we have the physical interface IP on the physical bridge, and all the port connect to the integration bridge, and they are patch port between these two bridges.
Well, I mean, for me, the two approaches are really similar because even I think now for bump traffic, we just install default drop flow in the first table. So even if we're in failure mode, like standalone, I would imagine all those broadcast packets that we don't want are just like dropped by the first table in the OVS pipeline. But I feel if the best practice is to have those two bridges, and if like this is what they do in OpenStack, and that people working with OVS and VM or container networking are used to that approach, then I think we should also go with that approach.
Yeah. I think maybe we can also check with Open Research team to say they also believe it's practice or not. Maybe it is, just like I don't know. Another thing that I still guess it doesn't work for Kubi proxy. But maybe we can discuss more offline.
Yeah. Let's look at the Kubi proxy part.
Oh, actually, I had one more concern that's not in the document. If I can just say it quickly, I think the only thing, but I think it's common to both approaches, is we have to be careful not to lose connectivity when we attach the interface to the bridge. But I think that's a common problem. And
right. So the connectivity will be. I mean, if it's TCP, right? I don't envision we're gonna lose connectivity, right? Because this is TCP. TCP it's gonna be in the container namespace. We're gonna just maybe lose a couple packet, but everything else should remain the same. That's my thinking right now. Yeah.
Do either of these solutions introduce any special cases of interpod traffic on the same node versus other nodes?
Interpod traffic
from two pods on the same node versus pods on different nodes. Are there any special cases that a user needs to be aware of?
No, this is the design only for the pod from different nodes. The pod from the same node remain the same. There's no difference. There's no need going out of the node. Therefore, the traffic just directly being routed by the OVS bridge.
I guess it's not. It will not be influenced by whether you have two bridges or one bridge. But actually, for the port forwarding, I guess we need to look at the public clouds. They probably have different configurations. Maybe it's not just as simple as we just do bridging for local ports.
Yeah.
And then send to uplink for remote ports. Maybe we still need to do some special processing for the packets for different clouds. For the coding, I think one thing that if later have multiple interface, I'm not sure what does that mean. I mean, if we want to be able to control which interface to egress the traffic, if all the interfaces are the physical bridge, I guess either we add some flows to the to the physical bridge too to control that, or maybe we just do that with DNS routing. If we have that use cases later.
Yeah. All right. Shall we move ahead?
Yeah, let's move on.
Okay. So can we go in, Antonio, can you going down a little bit? Yeah. No. So this is a no encap mode where if you look at the diagram where the container is getting a IP address from one of the node siders. I'm sorry, the pod sider, and the routing table has all the routes, all the pod sider routes routed pointing back to the gateway 0 host gateway GW0. I also have the IP table and also IPVS for load balancing, just for clarity. Transport bridge is created and extended, right? Right. Yeah, and also in this case, there will be no tunnel port because because all the traffic will go unencapsulated. Jianjun, do you want to discuss whether there's a need for this mode, or you're okay with a separate mode, other than?
I'm not sure what to do in this meeting since we don't have much time.
Okay.
For the high level, I'm asking, do we need this mode, or we just do hybrid mode, or maybe should we just prioritize hybrid mode?
Yeah. But my reasoning is that we don't know what the underlying network look like. So even essentially the subnetting, just checking node IP address, it only tells us on the logical level, on the IP level, where whether the nodes belong to different or same subnet, right? It doesn't mean the nodes actually are on the same or different physical segment.
I see. That's one.
So if the node in the physical on the same physical segment, regardless whether the subnets are different or not, we still can use no encap, right? Without overlay.
Okay.
Okay.
For that one, I'm not sure it works. I mean, if the remote node is in a different subnet, anyway, yes, the traffic will be sent to the gateway first.
It will be sent to the gateway, but gateway IP address is CIDR gateway IP address. Is not known to the physical network, to the underlying network, right?
Sure. I mean, the underlying gateway. I mean, if these two nodes are on different subnet, even they are in the same physical layer 2, the packet will still be sent to the physical, I mean, the underlying gateway first.
No, the traffic will be sent to the 10.10.10.1, for instance. That's the CIDR's gateway, pod CIDR gateway. Right. I hope that makes sense.
In our case, we typically do subnet per node, right? So that gateway is on the bridge.
So when we do, I think when we do ARPing, when we do ARPing for the gateways actually are the host gateway's IP address, right? That's gonna be GW0's IP address.
Yes.
Right, and that IP address is not known to the underlying network anyways, right? Right. So if for as long as the node are on the same physical segment, we should be able to ARPing for those gateway IP addresses.
That is true, but once the packet enters the physical network, enters the underlying network.
If the underlying networks are on different physical segments, that won't work. You're right. Right.
Even it's the same segment, but the two nodes are different subnet.
Right.
Oh, that's what I mean by segment.
If they're on different subnet, right? So subnet, those are the physical IP address.
Sure, I got it. I thought you mean the same, different subnet for the same segment.
Okay. When I say subnet, I mean the IP address CIDRs. When I say physical segment, that means actually attached to the same wire, same switch.
Okay.
Yeah. Okay. Okay. Now, so when we have in this mode, when we initialize the agents, there's not much changes required. There's not change needed as far as setting up the flows are concerned and routing table is concerned. We're still gonna add the a IP address to the local gateway. We're gonna still setting up the L2 forwarding table to forward traffic with the gateway 0's MAC to gateway 0 interface. And can we going down a little bit? Right. And one part is attached. We're still gonna setting up the pod address corresponding to the pod port. We're gonna add a L3 forwarding table to change the destination MAC address to pod's IP address if the following match, if the gateway, if destination MAC is gateway 0 MAC, if destination IP is pod IP. And then we'll set a classifier on the patch port so that we only allow traffic destined for this particular pod to be allowed. So that's how we ensure the security, that all the traffic coming into the integration bridge are to and from the pod traffic. The last one is that when the peer node is detected, we're gonna add in the L2 forwarding table to send traffic to patch port if that destination IP is peer CIDR, peer pod CIDR. Actually, that should be peer pod CIDR, not peer node CIDR. And we're gonna also add a host route with the destination equal to peer CIDR, right? So this is no different than what we have today, right? There are very little changes in fact to get this to work. So that's kind of good. Then we're gonna walk through the workflows for data path flows.
What about the ARP? Oh, maybe you handle this later. What about ARP to peer gateways?
Okay, so, yeah. So
if
you look at here, the ARPing to the peer gateways, if you remember that in the encapsulation mode, when we add in the peer node, we're gonna add a ARP responder flow, right? To emulate, to return the local host gateway MAC address as peer's gateway IP address, peer gateway IP address, right?
Yeah, and are we still going to use a virtual MAC address for all the gateways?
Yeah, in this case, we don't have that one. What this means actually that the ARP entry is going to be, the ARPing will be done directly over the patch port and to the integration bridge, right?
I don't see how that's going to work. Like, let's say the host network is going to send an ARPing for 10.10.20.1.
Let's say let's say that the peer is 10.10.20. Actually, that's
20.1. This one.
20.1, right? So we're gonna send ARP request to 10.10.20.1 over the gateway 0 interface.
Yep.
Right. We're gonna send ARP. ARP gonna be arriving at ARP responder table.
Yeah.
And there will be no matching, and it's going to follow through to the normal flow. There's a default normal flow for ARP responder table, which is basically saying treated as regular ARP, treated as a regular bridge, right? It's going to broadcast this ARP request to all the port, including the patch port.
Yep.
The ARP request sent to the patch port and out of the uplink.
Okay.
Right, on the response side, similar things. ARP request can be received by the physical bridge, gonna received by the patch port, then will be forwarded, will be broadcast to gateway 0. Right, gateway 0 sees how this is my IP address. It's gonna response and coming back.
Okay.
So you mean it's this route is unlinked route? I mean,
yeah, it has to be, right?
That's what I mean, right?
Sorry, can you repeat the question?
I mean, this route you added to the host routing table, it's an unlinked route, right?
It's unlinked route, yes. Yes.
I see. By the way, it's different from my original idea.
Okay.
Originally, I was thinking we just add the route to be the last hop to be the node IP, not the gateway IP.
Yeah, the reason I do the gateway IP is that I mentioned that this is for services that were to allow the I think the destination pod IP address to be re-enter the integration bridge to allow network policy to be applied properly. So if we put the route the pod sliders to the physical bridge or to the uplink, that means let's say you have a traffic for service, right? Those traffic for service will be directly going out of the physical link without re-enter the integration bridge.
I see.
That's
you mean the node to port traffic?
Yeah. No, not pod to pod traffic is okay. Pod to service traffic is not okay.
I see.
That makes sense, right?
Yep.
Okay. I'm just to rephrase. I'm doing everything here follow exactly same flow for in-cap. We don't want to reinventing the wheels. I just want to make sure that take advantage of what's already working and trying to add onto it. We're not trying to do anything different than the existing workflow in general.
Let me think about it. I guess one difference that in your case, you will have up to the gateway IP
Yes.
in the underlay network.
Yes, exactly.
I'm not sure it will have any issues. Not.
There's no proof, right? I don't know whether it's working or not. It just seems to be. It should be working, but I don't know.
I mean, at least you require the underlay switch disable this up looping, I guess, to make it work.
Yes, right.
But if you use the node IP, you don't really need to disable up looping, but you need to disable you still need to disable the source IP check, but not the up looping at least.
Yes. Yeah.
Okay, I'm not sure.
Okay. All right. So can we go down a little bit? So I'm just walk through the pod-to-pod traffic. The RPing is to the gateway, to local gateway. Then the pod IP traffic is sent to gateway 0, GW0, and we're gonna then the traffic will be routed back to the gateway 0 with no max rating. Then actually no. Right. Then we're gonna do the RPing for the remote gateway 0's IP. Then the pod IP is gonna the pod IP traffic will be sent to the integration bridge. It's rather, I think, too much details. Do you guys want me to go through the flow, or you guys have some particular questions you guys want to ask? Maybe that's better approach.
I think people can look at it after the meeting.
Yeah. But you have a question regarding some of the workflow, right? So maybe we can discuss that one specifically.
Yeah, I have one more question here. So you mean in your case, the traffic will go to the, let me think about that. The traffic will still go to the, no, it will not go to the physical interface. Okay, so the traffic will go to the physical bridge.
Which flow? To pod to pod or pod to
pod to pod? Okay. It will go to the physical bridge and directly to the integration bridge, right? It will not go to the physical interface and the physical bridge, right?
Right. So the pod traffic first arrive at the gateway 0 and arrived at the host network space, right? And get routed back. Right? Get routed back. Now, it has a different next hop, right? The next hop will be different. Then we're gonna do RPing for the next hop. That next hop will be the gateway 0 of the peer node.
Actually, this is a question I have. I also said earlier, I think it can be better if we can avoid the pipe enters the default namespace and Linux routing for performance control.
Okay. Okay, so we're saying that, but we still, I would imagine we still need, how do you do RPing if we don't enter the host namespace? I don't know, you can do the RPing easily.
Could we do something inside the OS?
Well, see, the RPing for L3 through OVS is pretty complicated, right? So
yeah, I know.
I think in the NXX environment, basically you're sending out the packet to the agent. Agent is going to generating the RP request on behalf of the as if it is a router, right? So it's a bit more involved. In this case, actually, we just let the host network stack doing the routing for us. That seems reasonable. I mean, right?
Okay, sure. How about this? Let's discuss more later on. Yeah, Father, I think you got my point. I basically just thinking if we can have a mode,
right,
at water flooding done by open with switch, it can have best.
But yeah, I understand what you're saying, but I would think this is orthogonal to this because this is even today for any mode we do the same thing, rely on the host network space to route, right? So that does not change that.
That is true. But only thing that for the tunnel mode you have no choice because we do tunnel by the OS. But for this low income mode or the public cloud mode, maybe we have a choice.
You're gonna make things more difficult. Well, we're gonna make things more complex if we do that because the RPing in general are not necessarily easy to do, right? So
Okay.
So that's that. You also have some questions regarding to the other mode, right, Jianjun, or anybody else has some questions too?
I don't have any more for this mode, but should we talk about your low in cap mask code?
Yes. Because the hybrid mode is actually just a combination of the no in cap and in cap mode, depends on the peer node's IP address. There's no difference other than that. So we can perhaps skip that. Yeah, let's go to the next one, no in cap mode. Yeah. All right. So in this mode, essentially, what we're saying is that the Antrea agent knows absolutely nothing about IP addresses of the container. Container itself has direct access to the underlay network. Then it gets the IP address, whatever means necessary, getting the MAC address, whatever means is necessary. In this case, the traffic, there will be no gateway IP address assigned to the gateway 0. The gateway 0, the presence of gateway 0 is solely for forwarding the POW to service traffic to the host namespace so that it can be load balanced by Kubi proxy. Now, I think Jianjun, you have some questions regarding to this approach, right?
Yeah, my main question is just about this Kubi proxy.
Yeah. So let's walk through the Kubi proxy. Let's walking through the POW to service workflow.
Yes. Yeah, can we do that? Because I don't understand how it works without an IP address assigned to gateway 0.
Okay, can we go down to that workflow there? Right. POW to service, right? So the first thing is that the service IP traffic is sent to gateway 0 VDNet IP table, right? So the gateway 0 interface received this traffic. Then in the pre-routing chain is gonna be forwarding to the proxy, could be proxy rules and do load balancing, right? Then one of the pod IP address is going to be picked by the IPv6 or IP table rules as a destination, right? Then the destination IP becomes a pod IP address, right? Now, because the traffic has ingress of gateway 0, then when in the forwarding stage, we're going to pick the customized route table. Now it's the default route table, but customized route table, which says that any traffic coming from gateway 0 will be sent back to gateway 0, right? And in the gateway 0 case, we're gonna have we're gonna have I think a unlinked rule to say that this is gonna be default. All the routes are on this interface. Then the gateway 0 interface is gonna do a ARPing for the peer pod. Once questions.
So you are saying, so even before talk about the service traffic, for the port-to-port traffic, in that mode you have a route to say the node subnet next hop is the peer gateway IP, right?
Right. Port-to-port traffic does not go to the host gateway host namespace.
Sure. Maybe I should say node to port.
Node to port will right?
Yes.
Node to port will go from the node from the host namespace to integration bridge.
Why?
To physical bridge. When the ARPing will be resolved on the physical bridge. So the traffic would go from physical bridge 172 the physical bridge and going to, so the ARPing will go to the physical bridge, right? Then ARPing reply will be coming from the physical bridge.
In your case, I mean, for the low encap mode, for your low encap mode,
yes,
you have a route to say the remote port subnet. The last hop is a remote remote node gateway 0 IP, right?
Yes.
But for this mode, you don't have a gateway IP. And what the route will be like?
The traffic is going to go directly to the physical interface, to the physical bridge. The default route will be a physical bridge.
I see.
Right.
The default route will be the physical bridge.
Yeah.
So
you route everything in the host names. You route everything to the physical bridge because.
But how the physical? Okay, go ahead. The traffic go to the physical bridge and then
going to the physical bridge, and physical bridge is gonna do gonna send our broadcast ARP request to all the ports attached to it, which is gonna be patch port or uplink. So if the pod is on the local port, on the local node, the container A, for instance, will respond to ARP request, right? Then
so in this case, since the port IP, I mean the remote port IP is in a different subnet, the Linux routing style will just TTP style will just drop the packets, no?
What remote IP you're referring to?
I mean, for the node to remote port traffic.
For remote pod, right? So keep in mind, so basically, let's say you have a remote pod, right? The traffic, let's say we do ARPing for that remote pod, right?
Why you do ARPing? I mean, if it's in a different subnet, you have a low route or not reachable.
Oh, if they're on a different subnet, then we're gonna find the gateway. We're gonna ARPing for the gateway, right? For the physical gateway.
Okay.
So the remote pod If it's a node pod, keep in mind this is actually we're doing routing. Routing is going to be done by the underlay network. We don't.
I see.
That makes sense, right?
Yeah, makes sense. Yeah, my mistake. I thought it's like we underlay I would understand a lot. I see.
Yeah. So the bottom line here is that port-to-port traffic stay within the OVS bridges. It did not go to the host namespace. Only port-to-service traffic or anything to service traffic going to the pod to the host namespace, host network namespace to do the load balancing. Once the load balancing is done, we force the traffic going back to the gateway 0. Then we'll again then go through the network policies and send out within the OVS bridges. That's the logic.
Okay, so we're running out of time here. I also think that I also agree with Janjun's comment here that we should prioritize this use case for using Antrea in the public cloud.
Yeah.
I think one thing I'm still not clear about is motivation for the other use cases. I think this one makes sense to me because of what I know for Azure and AWS.
Yeah.
So I would think we should start with this one.
Yeah. I think this mode is also a requirement for actually we wanted to extract the pool manager, mandatory pool pod IP manager. That's mandatory today, right? So that need to be mandatory. That need to be extracted out because in the no in-cap mode in public cloud cases, there's no pod manager.
Yes, exactly. So I think that mode is
there's additional work need to be done in order to really support public cloud, right? So yeah. This is baby step. We're gonna do this. I imagine we're gonna start to implementing and see. This is just very high level. So I'm sure as we start implementation and testing, we're gonna find more issues. But that's how things goes.
Okay, thanks for walking us through the proposal, Sue. I did say at the beginning of the meeting that we're considering moving to a bi-weekly meeting cadence, but I think since we use the whole time for this proposal this week, we may want to still meet next week to talk about like the 0.3 release, and I think Cody has been working on some project boards, so maybe he wants to present that.
Yeah, definitely. There's two things I'd like to present at the next meeting. Not only the project board, I've also been working through some more detailed project governance in terms of how we will triage issues and try to have a little bit more of visibility in as issues are coming in, making sure how they're getting selected for prioritization, tracking progress towards milestones and releases, that sort of thing, so that we can provide a more visibility from a dashboard perspective of where we are in reaching each milestone. So I will be submitting a PR at the end of the week with all that documentation, and if you could get a chance to review it before the next meeting, that would be great.
Yeah, awesome. So I think we should definitely maintain the meeting next week to talk about this, because we definitely need to streamline the process to like attach issues and PRs to milestones. Okay, we're out of time. Thanks everyone for joining, and thanks Sue for presenting this. I think we're going to keep the discussion offline on the Google Doc and on the mailing list and on GitHub. So thanks everyone.
Yeah, thank you. Bye.
Thanks. Bye-bye.